In this video, we're going to use the Fundamental Theorem of Calculus and the chain rule to find a derivative of an integral function. And it says, given f of x, capital F of x below, find f prime of x. And it says, capital F of x is equal to the integral from 3 to sine x of t squared plus 8 dt. You'll notice we have sine x here, and we've been used to having just x up there. And our fundamental theorem works for when we have the integral from a to x of f of t dt, we know that we get f prime of x is equal to f of x. But when I have, let's say I have u to the x up here instead, then I would end up with f prime of x would be equal to, this would be f of u of x, and then this would actually be du over dx, because I have to take the derivative of u of x, and because I'm doing that with respect to x there, I end up with this implicit differentiation there. So we're going to use this piece right here with this function. We're going to say that we really need to substitute something for sine x. So we're going to do that here. And then we're going to get f prime of x would be equal to, when we substitute u of x, we put that piece right there. So then we would have u of x squared plus 8 times du over dx. So then we're going to do some substituting in. So f prime of x is equal to, this would be sine of x squared plus 8. And then this would be d over dx of sine x when we substitute u in to that equation. Well, we know the derivative of sine x is cosine x, so we end up with sine squared x plus 8 being multiplied times the derivative of this would be cosine x. So we're going to end up with sine squared x cosine x plus 8 cosine x for f prime of x. And so you can see we had to use a little bit of the chain rule there to finish this problem out, because now we don't have x here for our upper bound, we have sine x, which is going to cause us to use that.